Two spheres have the same positive charge. A point M is midway between the two spheres. Along the line joining the spheres, what is true about the electric field and electric potential at point M? Okay, let's consider the two spheres as 2 point charges, positive charges. Let's say plus Q and plus Q. So we need to see what is the electric field and potential at the midpoint. We know that for a positive charge, the electric field is away from the charge. So at this point, electric field due to the first positive charge is away from the charge. Due to the second positive charge, it is also away from the charge. So they are opposite in direction. And their magnitude K Q by R square, where R is the distance between the charge and the midpoint, which is same for both charges. Also the charge magnitude of the charges are also the same. So since they are being equal and opposite, they cancel each other. Let's say if we take E1 and E2, so E1 and E2 are equal and opposite to each other, so they cancel each other. So total electric field is 0. Now let us look at the potential. We know that potential due to a point charge is given by kq by r, where r is the distance from the charge to the point where we are finding the electric field. Again, the distance from the charges to the point where we are finding the potential is the same. We also know that potential is a scalar quantity, so it is just total potential will be sum of the algebraic sum of the potentials. So the individual charges are positive, so potential due to the charges is also positive, so we need to add the two values, so the total potential will be positive. Okay, then will it be maximum or minimum? So that we need to check. Okay, so we know that potential due to charge is inversely proportional to distance. So if you see the first charge, as you go away from the charge, the potential decreases. So in between the line joining, here at the point M, the potential will have the least value from the positive charge. Same way from the second positive charge also, it will have the least value. So those least values add up to give the minimum positive potential. So the answer is A. Or let me I can also take an example and check. So let me take this total distance as 10 centimeter. So let me consider a point P. So let's say this point P is 1 centimeter from here. Okay, and this distance is then 9 centimeter. So potential at the midpoint will be, let me find the potential at the midpoint, total potential, which is V1 by V2. So K charge is the same, so KQ 1 by 1 plus, okay, so I have to take SI units, but it's fine. I'm just taking it as an example to show the values. So this is 1 by 1 plus 1 by 9, that is the distances to the charges, which you will get it as KQ. So when you take common denominator, we will get 9 plus 1, 10 divided by 9. So I'm sorry, this is the potential at this point. So let's say at the point P, not at the midpoint. So now let's see what's the potential at the midpoint. Again, V1 plus V2. To the midpoint, the distances are 5 and 5. So 1 by 5 plus 1 by 5, which will give you KQ 2 by 5. If you see this, VP is greater than Vm, that is potential at P is greater than potential at M. So they are asking for the minimum potential at the midpoint, so definitely it is less than the potential at point P. So we can conclude that potential at M is the minimum, will have the minimum positive value. Hence the answer is A. Electric field is 0 and the value of potential is minimum and positive value.